Okay, awesome. We've already kind of seen a lot of these data structures. Um, we're going to go into a little more detail in them today and spend a little more time on linked lists. And really this afternoon, you all, I think, will have plenty of time to practice implementing them. Andrew asked a really good question earlier about like, hey, when am I actually going to use these? And the answer is directly not often. Again, this is really foundational knowledge. It may come up in technical interviews, like implement a stack or implement a linked list, or implement a queue. And these are sort of like the very basic building blocks. Like if we wanted to build our own database system or our own email client or like our own, it's called like a sort of a job queue or publish subscribe system. Like then, we might start reaching for some of these data structures, and they're usually used in conjunction with other things, right? And like the browser history is not the worst example of a stack. I mean, it's actually a list because you can go back and forth, but you can imagine if I was like building a browser, well, I need to store that history somewhere, and I don't want like you're not really meant to be able to jump to any random point in the browser history. It's really, going back and forth. So it makes sense to kind of like limit access to that data structure in my program. So again, even if we're not directly implementing like stacks, queues, or linked lists or trees, as we'll see tomorrow, we often will be doing things that feel very similar, and the patterns are very useful to know. In terms of, I don't think we directly test this on assessments, and we won't be using a ton of it further in the course, but it is really valuable and important stuff. It's also the keys to the kingdom. Like this is a learning field, and stuff is always changing. So the more you can learn about like the sort of core foundational knowledge of like how computers work and computer science and programs, I think the more that sets you up to like have really successful careers and be able to learn whatever new things come up. Also, again, this is sort of like common knowledge among software engineers, and even if we're not implementing it all the time, there is sort of an expectation among your peers that like, hey, I'm not an expert at recursion. As you can see, like I'm a little rusty at it, but I get what it is. I know what a stack is, and so on. So we've already talked about this. I've just sort of used this nifty little tool called Reveal.js that lets me turn a Markdown doc into a slide deck. So this is our curriculum doc. And we've seen the call stack here, which is called the execution stack, because it is indeed the stack determines the order in which our program executes stuff, the order in which the computer executes stuff. And so like it'd be a great exercise to throw Clarice's countdown code in Python tutor and see how like where that print statement is relative to that recursive call like changes the order of execution, and how that makes the program change. That was a really neat implementation there. And I think Python tutor is a really good tool to use, and I'll try to come up like Sean and for other folks, I think I'll try to see if I can't come up with like sort of like the hello world of recursive algorithms that will really, like when you put it in Python tutor, helps illustrate stuff. So a stack, I think we're all familiar with. Everything goes on the top of the stack, and everything is removed from the top of the stack. This is called last in, first out. And this is worth remembering because when we talk about a queue, which sounds pretty much like what it is, a line, the British word for line, that is first in, first out, FIFO. So you will see like LIFO or FIFO. Those are common terms of art that it's good to be familiar with. So please do just write down somewhere in your notes like stack, LIFO, last in, first out. And here's just a nice little diagram of a stack, right? Where we push and we pop. And I just want to check and see if people have any questions or just anything that you're curious about.
I have a question.
Yes, sir.
Again, just on terminology, is a call stack the same as an execution stack? Are there different kinds of stacks or just one stack?
Great question. Call stack, execution stack, synonyms, basically. Synonymous for the same thing. I think the correct term is call stack. I'm not 100% on that. But as you see, like I borrowed parts of this lesson from our lead evening and weekend instructor, Chad, who's awesome. He's a code platoon grad and he's a data engineer. And so he used the term execution stack. So it does get a little confusing. So please do keep asking. And the more you do it, the more comfortable you get. But call stack and call stack execution stack are the same thing. And in terms of the stack data structure, I think there is basically one way to do it. There are probably like some choices you make in implementation that might have minor changes, but otherwise I think a stack is a stack. Which is a great question because like with trees, for example, you've got like a binary tree versus not. So with the other data structures, there are like more variations.
Got it. So there's just one stack.
Yeah, pretty much.
Thank you.
Totally. Great question, Andrew. What else is on people's minds, or what other questions do people have? Yeah, and I'm always a fan of terminology questions. And Megan, I see you're saying in the chat, arrays can be used as a stack if you push and pop on the end. And that is totally true. And that is because a JavaScript array is not a real array like we were talking about on Monday. And a Python list, I think, has that push pop behavior as well. Like for a real array data structure, I don't think it has push pop added, but with JavaScript, we all call them arrays and they have push and pop and stuff. So it does get the terminology and the usage is genuinely fuzzy. My favorite example of this is the language JavaScript, which you all know has absolutely nothing to do with the language Java, which many of you don't know. JavaScript was created in about a couple weeks in the 90s by a guy working at Netscape, Brendan Eich, and they named it JavaScript to sound similar to Java for marketing reasons, because at that time, this thing called Java applets, there was a way to like run Java in the browser as an applet, and people thought that was going to be the big thing that took over the web, and it went nowhere. But they were like, we got to name this language JavaScript so it sounds like Java, so we can get people and companies on board. And lo and behold, JavaScript ended up taking over the world. Java obviously is still extremely popular, but not in the browser. And just to make things more confusing, Java has a virtual machine. And then I think JavaScript also like has a virtual machine. And so the Java virtual machine is the JVM. But for if we're going to talk about like the JavaScript runtime engine, like all the terms and names, there are genuine points of confusion is the point I was trying to make, that I probably overly belabored there. But there are genuine points of confusion. So please definitely continue asking any and all questions. JavaScript also, by the way, though it looks a lot like Python and it kind of looks like C, or it kind of looks like Java, the way the language actually works is actually pretty different in some ways, just to make things more confusing. And here we just have a great diagram that I like of a polyp, where like this jellyfish like creature only has like one in and out tube for everything, just like a stack. And I thought Chad's choice of this was really inspired. So while we get to look at this fun diagram, let me talk about designing a stack. There's basically three things that we can do with the stack. We can push, we can add an item to the top of the stack. We can pop, we can remove an item from the top and return that item so that we get the thing and we can do something with it. We're both modifying the stack and returning the thing that we're popping. And peek, where we return the value of the thing on the stack, but we don't remove it. Right. And that's, I think, the method often ignored sometimes in talking about the stack data structure is peek, and that's very useful. I also want to very briefly mention the use of the term API, application programming interface here. Speaking of terminology, application programming interface is probably one of the vaguest things out there, though it is like a very concrete, like it's a useful concept. So according to the internet, like what is an API? An application programming interface, a set of defined rules that enable different applications to talk with each other, an intermediary layer, blah, 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 blah. So super vague, right? What is an application? We haven't talked a lot about interfaces in object-oriented programming. Am I correct in thinking that I don't think we touched on it that much last week? Can someone just give me a confirmation there that we didn't really look at interfaces all that much? Or if we did, please let me know.
I don't think we did.
Yeah, I don't think we did either. There's a lot of stuff that's cool with object-oriented programming that's also sort of out of scope, and it's less critical, to be honest. The very short version is in object-oriented programming, the same way you can define a class. And I'm actually not sure off the top of my head how this works with in Python. But you can define an interface where I can say, all right, like my interface for the stack class has to have a method named push, pop, and peek. But I don't actually define any of that stuff. And then I can create like a class Adam's stack of dishes that implements interface. And we don't, this is not, we don't have to worry about this too much. We're not going to be implementing Python interfaces. In fact, I'm curious to see like what the formal, I don't think I have like set an interface in Python. So I'm not going to go down that rabbit hole. Python might implement it in a different way, but I wanted to talk about the word interface relative to this API, application programming interface. And many of you have probably heard of like a REST API and heard the term API used in reference to like a web apps API or like the Netflix API or the Spotify API to get information about songs and stuff. But the general concept here is basically like we've got different programs and we want them to be able to talk to each other, and they need to know like how to talk to each other. They need to, it's like the puzzle pieces that fit together, or like they have a common language, or even for other programmers. So you'll hear the term interface, you'll hear API, though once we get into like web stuff, that'll be used in a very specific way. I might sometimes talk about like separation or boundaries. Basically, like what does my class do? What does it not do? What are public methods? What are private methods? What methods are exposed? So, right, we're going to implement the stack class, and the interface is the stuff that some other program can use when they use our stack class, right? So these methods, and really, and so I went on a bit of a tear there. but I know that like talking about like interfaces and APIs can be like a little confusing. And I just want to get you all to start thinking about like, what are the boundaries between the different parts of my program? Like, and how are these things meant to be used? And this is pretty straightforward, right? We can create a class named stack, and we have these three methods. We're not going to worry too much about getters and setters. And so we would say like, this is kind of like our interface, right? This is if someone else is going to use the stack, they're going to use push, pop, or peek. And I want to just pause and check in and see if folks have any questions. Brian, great question about interfaces. Would a command line input menu be considered an interface? Does a program need to move beyond the command line to properly have an interface? Great question. I would say that's a really good analogy. Command line input, usually that's there for us humans, right? That's like a user interface. The way that I'm talking about interfaces here, it's about how does some other part of my program use this stat class. So it's not like sort of like the user interface, and the word gets used that way too, but it's like when I'm writing this stat class, what are the bits that I want like other programmers or other programs to use? So it's not strictly like a user interface, but it's like these are the methods that when I use this somewhere else in my program and I instantiate and create a new stack, like we're going to use push, pop, and pass. We're not going to be using anything else that we add here. So, the other metaphor that's often used is, for a car, the interface is like the steering wheel and stuff like that. Except this interface isn't for people, it's for other programs and for other programmers to see like, all right, how should I use this thing? Does that help a little bit?
Yeah, that helps quite a bit. But just for kind of understanding check. So then would the example of like importing our whatever class from one file into another file for the use inside of a different class, would that be then an API?
It's a great question. Importing is just sort of its own thing of I'm gonna import something and then use it. All these terms are pretty fuzzy, to be honest. Like, and they all get used colloquially. Like, most of the time when in this class, when you hear API, we're going to be talking about REST APIs. And like, we're going to get to this much later, but like, there's like a very certain way that like when you write a web server, you can send and receive HTTP requests. Someone give me a Pokemon name here.
Ditto.
Bizarre.
Squirrel.
What?
Squirrel.
Squirrel. Like somewhere, Squirrel's not there. Or I spelled it wrong. I'm gonna do Charmander because it's the only one I know. So this is, let me just very quickly, without going down too big a rabbit hole here. Like if I use this curl command that sends an HTTP GET request to a URL, that server sends me back this giant JSON object with everything I could ever want to know about Charmander. And there's like a whole standard format of how to write these URLs. And that's what's often called like a REST API. And we'll talk about like the APIs of our web applications. Because if I'm writing a web server, I don't have methods and classes that someone can use over the internet. But as a server, I have URLs. So my interface is if you send an HTTP GET request to this URL, Pokemon/Charmander, I'll send you back Charmander's data. Or if we look at, I don't know the Pokemon well enough. But if the URL has Ditto, I'll send you back his data. So that's normally how we're going to be using the word API. Again, with the colloquialisms, sometimes you might hear people talking about it about like, in this case, it's talking about like the different methods on this class that other programs are supposed to use. And if it's a little fuzzy now, that's okay. That this is a little, I went a little out of scope here. So I wouldn't worry about it too much. And please do just keep like asking questions as it comes up. There's not like we'll talk about like REST APIs and that has like a very specific meaning. But other than that, like all of these terms usually are used in pretty fuzzy ways. And it's really, a lot of it just comes with practice. What other questions actually do people have before I move on? And Brian, I apologize that I did a little bit of hand waving there at the end.
Hand waving is cool.
Okay, awesome. Oh, and I see someone shared a link, which looks very cool. That, yeah, this is a great link. We're going to be looking at this stuff later. Matt, if you don't mind maybe throwing that in a Slack channel somewhere for us to come back to, that'd be for people to look at, that'd be awesome. But that's sort of a preview of a couple weeks from now. So I'm going to go ahead and start implementing this, in fact, so that we can have some code. But you can kind of see where this is going, where like, there were some really good questions about how do I use these data structures. Well, if we're implementing a stack class, and we could implement a stack in other ways. We could probably use a dictionary. We could probably use a function, but Python is an object-oriented language, so we have classes, so it's an easy way to do it. We need some other data type to store the stuff in the stack, and in this case, we're using a list. If we were using Java or C or doing this at like a lower level language, or if we traveled back in time to like 1972, then we would use an array, right? So this is a good example of how these sort of data structures get combined. And let me go ahead and start writing a little bit of code so that we can run it in a bit. And while I'm doing this, if anyone has any questions or things that you're curious about, please let me know, because now is the perfect time. And this, I believe, is a Python type annotation, which is very cool, but a little outside the scope of what we need to worry about. Let's see what this little blue squiggly is here. And I'm going to add my doc strings just because I really don't like squigglies. Normally, like if I'm writing code that's not sort of for teaching purposes, I am pretty serious about like documenting like and having good comments for everything. So I like the reminders. Let's see what this says. Unnecessary pass. All right, well then we can get rid of it. And in the vein of what I'm always saying about always running my code, I'm just going to run this. And the reason I'm putting the print statement after my stack is just in case I have some sort of error or for some reason this breaks, we would never see the print statement, but that's pretty unlikely. And just give me one moment, folks. Okay, awesome. So this isn't test-driven development, but I make typos all the time and it's easy to miss them. So even though my stat class doesn't do anything yet, by actually running it and making sure it works, I've confirmed that I haven't, like, there hasn't been any programmer error. Right. And I have this and I know it's 100% ready to go, which makes adding things onto it really easy. And now we want to do push and pop. Megan, like you were saying earlier, like the fact that JavaScript arrays and Python lists have this stack-like behavior built in because it's so useful makes this really easy. Right. So in a lot of ways, the implementing a stack is pretty straightforward. So that's our push. And in fact, what I'm going to do, I think, is let's put this here, maybe. Let's print an F string stack base. Let's see if this works. I want to print out the list of everything in the stack, which indeed is nothing. And now let's push something onto it. Let's just push. Hello? Doesn't matter what I push. I just want to, again, like, there's no reason not to, even if I don't have tests, like, sort of embrace that approach of just every time I write a little bit of code, add something so I can run it to confirm that it's working correctly. And now for pop. I believe we just have to do that. So now let's go ahead. And in fact, what I'm going to do here is I am going to add a method. No, I shouldn't add it to the stack. That's not properly correct. I wanted to. Let's do this. Excuse me. And I guess I don't need the F string if I'm doing it this way. Let's make sure that that helper method works. Awesome. So now let's push another thing on there. So if we wanted to get fancy, we could add print base as like a private method and sort of indicating to other programmers that you're really not supposed to rely on this when you're using this class. But just so I was talking about how fuzzy these terms are of interface, just so I can keep the interface of this stack class clean so that when someone else reads it, they see only like what is necessary for a stack. I didn't want to put this print base as a method on there. This is really a utility. This isn't really about the stack. This is about helping me like doing my programming. And if I run this again, great news. Hello world and just hello. So my push and pop, they're already working. And before we move on, I just want to check in and see if people have any questions or anything. Anything you're curious about, anything you'd like me to maybe go over again. And I know that some of this is probably reviewed, so I hope that the pace is okay, and we're definitely going to be getting into like linked lists a little later, which will be a little more interesting. But hopefully this is useful to see as well.
Hey Adam, I just have a quick question about it. Is this creating the stack class? Is this basically just to to organize and like standardize, the append and pop and all that. I guess I don't really understand why you need to create the stack when you could just go and append and pop this whenever you want.
Yeah, that's a great question. The reason is we may not need to a lot of the time. And again, the reality is like there aren't a lot of times where you will be actually implementing and using a stack. But like to use the example of a calculator and the undo behavior, where if like you hit that undo button, it undoes the last operation. Like if I'm building a calculator program, I don't want some other part of my program to be able to like randomly choose any point in the calculator history. Or again, think about like the back button on a browser, like forward and back, even though, since you can go forward when you hit back, it's more of a list than a stack. But if I was implementing that on a browser, I want to make sure that that is only forward and backwards. And in fact, let me just demo that very quickly, because that one is easier to demo.
So in a way, it's just kind of like enforcing a certain way for the data to be managed for your app.
Exactly. And the context here is that the context here is a couple things. As projects get bigger and you have teams of people, other people will be using this code, and you all will do some reading of code in this class, but really we need to build more in. But reading someone else's code and like understanding how it's meant to be used is a bit of an art. Reading someone else's code that was written 3 years ago and has had like a dozen other people modifying it is a whole lot harder. And so when you have teams of developers, someone might write a class or some code to be used one way, but you can't necessarily be guaranteed that like every other programmer is going to understand that or always do the right thing, or maybe they have a deadline or whatever. So a lot of programming is about like making sure that like other people can't use this in the wrong way. Which, if you have like a team of 20 and something that's been developed on over years, and when you all get out into the industry, you'll see just how much code tends to stick around. So there's a lot of this is more about that, like the dynamics of like doing this on a team. There is also what's called sort of defensive programming is a term. And that is, it's a little less relevant, but basically if some other part of my program screws up and starts doing crazy stuff, I don't want it to break this part. And that can be useful for all sorts of reasons, especially as programs get bigger. So there can be a lot of usefulness to like designing something like exactly how it's supposed to be used. That said, there will be plenty of times where this is overkill and it's too much work, and the fact that I can just do append and pop makes it way easier. The difference being, if I just see some list, and it's like browser history pen, I don't know, Wikipedia, right? And let's make this a list. If I'm a programmer and I see this, there's nothing indicating to me like, hey, I'm not supposed to just do, something like this. While with this stat class, it's really explicit, like what this is for and how it's supposed to be used.
Great. Yeah, that makes sense. Appreciate it.
Totally. Great question. That said, this is a little bit of a contrived example. And again, we will always be implementing stacks. So there is a piece of this here where we are doing this for learning purposes, for sure. And yeah, we are, as I see in the chat, like we are building ourselves a stack. And we're really doing this for learning purposes. There's not going to be an immediate direct application, though every now and then you might want to do a stack. And again, you will see sort of similar patterns pop up. But so what I wanted to show here in the browser is if we do like window history, I think it's pop. Oh, browser history pop. Yes, let's see what it is, in fact. Okay, so they have back, forwards, and go. They have history back. I thought it used to be like a pop method, in fact. Yeah, this is, no, it's still forward and back. I thought it was push and pop. So this is probably like a list, but actually this is a great example of everything that we've been talking about so when the browser starts up, it runs a bunch of JavaScript that gives you tools to interact directly with the browser. You guys may or may not have seen the window object, and then that has something, a property called history. And this has a whole bunch of stuff. And it's a big JavaScript object, but you can see there's a property here back with a function, forward, go, push state, replace state. So this is more than a stack, but it is a similar sort of thing that someone had to build when they were building this browser. And I can do window history back, and that actually moves the browser back, right? So again, we are probably not going to be building a browser anytime soon, but it is good to see this stuff and learn about this. And here is one example of how these things sort of get combined and applied in a more practical sense. We're almost done with our stack here, though. There's not too much left. We really just need to implement the peak. And here we're taking advantage of the awesome behavior of Python lists, so that I can use the -1 index to get the last thing, and we're not popping anything. And here is a good note right here. What happens if there's nothing in the stack and we do peak? What should we do? Because otherwise this might throw some sort of error if we don't have this if statement. So let's return none. And in fact, let's implement this without that and see what it looks like. And these are the sort of, that's a good example of the little sort of gotchas that you have to think about with this stuff, and why these things tend to stick around in technical interviews and fundamentals. Also, you know, in terms of teaching. So let's go ahead and let's print my stack peak. Let's make sure that works. Lo and behold, it works. Let's pop it again. So there should be nothing in there now. Let's confirm that it's empty with the print statement. And then let's peek again and see what happens. So lo and behold, our stack is empty. We peek and we get this index error, this index out of range, because I'm trying to look at the last thing in the list, or whatever exactly this -1 notation does. I believe that's what it does. Instead of, yeah, the -1 instead of 0, we're going from the end, but there's nothing in the list, so we get an index error, list index out of range, since the list is empty and we tried to access an index of something that doesn't exist. And if we were doing test-driven development, this is the perfect thing to write a test for, right? That our peak handles an empty list correctly. And I'm going to write this a little differently. So this is, you guys have sort of seen this pattern with recursion. This is often called a guard statement, where my bad path, my error case, my unhappy path is what I'm looking for in the if statement. And I return none. And because inside the if we return, I don't need an else or anything like that. And now this should work. So now I've got a stack. I just want to check in and see what questions people might have. And let me make this a bit smaller so we can look at the whole thing here. Not too crazy, right? Oh, and Megan, I see you saying in the chat, the leak code problem valid parenthesis is a good problem for using a stack to solve. That's an excellent point. And I was Googling real world applications of stacks, and there are all sorts of interesting things. Undo, redo, it get used in syntax, a lot of lower level stuff. And actually, Megan, what you were saying about the valid parenthesis problem is a great example, because parentheses, that's about nesting, right? Just kind of like with recursion, and just the same way that we can use a stack to implement recursion, as we saw, that's how the computer deals with functions and recursions. We can use a stack for like valid parentheses and stuff like that. Like you could probably use a stack somewhere for the Roman numerals problem in some way, like that, you know, if we wanted to. All these things are just tools. There's usually more than one way to do it. But again, this is more, we're doing this for learning purposes. So obviously, like if I do try to do something else with my stack, like just up here, let's say print my stack sub 1, I'm going to get an error. And in fact, this is already telling me unsubscriptable, which is a Python term for something where we can access any element, I guess. Or if I try to do, you know, my stack append, who, again, we're going to get an error. It has no property named append. So that's the other advantage of defining stuff like this, is that programming text editors are so powerful that they give us hints and reminders of how we're supposed to use this stuff. And the bigger our programs get, the easier this makes our lives. What's on people's minds? I think now is a perfect time for a break, and then we can look at queues and linked lists. But before we break, what's on people's minds? I see a question in the chat. Could you do my stack peak and then print my stack? Totally. And that's
Yeah, I'm not getting the same result doing it that way.
let me comment out. Let's comment out that stuff. Actually, just bring this right up here. Actually, I'm going to use my little print statement thing, because this helps me, because I found it's my own assumptions that usually cause most bugs. So I try not to make assumptions. So I want to see exactly what's in that stack, because I've had so many times where I'm like, how come peak doesn't work? And 45 minutes later, I realize the stack is empty or something like that. So whenever I can, I just want to get actual data. So, and then Andrew, you were saying, in fact, let me get rid of that. And then we want to print the stack again, which is a great call, because you're saying, let's make sure that peak is behaving correctly and isn't actually popping something off of the stack. So that looks good. Are you using this technique in your peak method? Or are you using like a pop?
I'm using the same technique as you.
Throw the code in Slack and let's take a look at it.
Okay.
Or actually, let's do break and then I can just look at it real quick right now in Zoom.
Sounds good. I'll throw it in the